right, can everyone hear me okay in the back? Give me a thumbs up. Oh man, I got salutes back there. So my name is Major, but there's no need to salute. So, all right. So my name is Major Hayden. I work for Red Hat, and my talk today is about don't tell me RAG is easy. And if you don't know what RAG is, don't worry. We'll get a full detailed explanation. How many people in the room have talked to an LLM before or talked to an AI model? Okay. Probably all your hands should be up because at some point you probably have, whether it's via the phone or whether, I don't know. It just seems like it's everywhere these days. So if you don't know the nuts and bolts of how all the things fit together, don't worry. I've got some refreshers in here for things like that. So we'll make sure we're all on the same level before we get going. All right. So the agenda is we'll do a quick refresher on what an LLM is and just a real high-level view of what RAG is. We'll also talk about the fellowship of the RAG. And we'll talk about the mines, and at the end we'll end with the road goes ever on. So some of you may be able to pick up the theme of what the presentation is. It's always, I love it because like usually I get like a first round of smiles and then other people are like, oh, when am I going to figure it out? So I can't wait to see like more smiles start popping up around the room. It's fun. Okay, so a large language model. So this, if you ever talk to ChatGPT or Claude or you've run a model on your laptop, it is a very sophisticated autocompleter. It is trying to give you something that sounds like the thing that you want. It is not understanding what you're asking it, and it's not understanding really what it's writing either. It's doing statistical probability to figure out what is the best possible answer that it can give you. So it doesn't have access to real-time information. Now there is tool calling that will enable that, but once an LLM is trained, it only has that information available to it. And I would argue that it's not reliable or deterministic. In some situations, for certain models under certain conditions, you can get them to a point to where every time they'll reply with a deterministic answer, but it's not guaranteed. And so there's a really cool toot or post or something on Mastodon. And this professor said, my students are often surprised to learn that LLMs aren't answering their questions. Rather, an LLM answers the question, what will a reply to this look like? It's one of the first things I explain in the should I use LLM portions of my syllabus. So it's something really critical to think about, is just trying to answer with something that sounds right, not necessarily something that is factually correct. So imagine hiring an intern with an unknown set of biases that will never learn anything new, that was trained by people you never met on a broad unknown set of topics, and then you put that intern in front of your most valuable users. That's an LLM. So I use LLMs all day long, and I love using AI-related products. And I can talk to you in the hall for like a half hour about how I used to not like it, and now I love it. But this is just still something we have to keep in mind. And I'll put a link to the slides at the end. There'll be a QR code, and you can download them all and all that. So how do we raise the odds of a good response? We don't know what it's been trained by. We don't know how it's going to reply. So your LLM needs a tool to be able to do that. RAG is one of those tools. So I put a little note down here. If you've heard anything about MCP servers, this is kind of like giving a REST API to an LLM, putting handlebars on a REST API so the LLM can grab a hold of it. It's a pretty interesting new technology, but all the security people in the audience will be scared of that one. All right, so what is RAG? It's three pieces. First off, you retrieve some information that's relevant to what a user is asking about. That's the retrieval piece. And then the augmentation is where you take the LLM's ability and take it to the next level to answer the question for whoever's asking it. And then finally, at the end, the LLM hopefully can generate a better response that's more complete and correct and coherent. So the way this works in practice with an extremely simple diagram is that someone asks a question or they bring up a concern to an API. So this is when you go and talk to Anthropic Claude or you go talk to OpenAI. Then what that system will do is it'll try and dig out of a database of documents, or it could be an API or a tool of some sort. To try and pull more relevant context about what that user asked about. Maybe it's things the LLM wasn't trained on, things like that. That response comes back, and then the user's query, the context that you got from the RAG database, and the prompt, which I'll get into a little bit later, is the instructions that you give the LLM on how to answer the question. All goes to the LLM to generate that response. And now hopefully, the user gets a correct and complete and coherent response. Sometimes it does not, and I'll get to that. So RAG's like an open note exam at school. How many of us have gone and taken an open note exam at school and then we suddenly realized we should have studied the material more? We assumed that the notes were going to be good enough, and then all of a sudden, you're wondering why you didn't actually do some more calculus problems in your homework. And so it's the same way. If an LLM hasn't been trained on the information that is close to what you're asking about, even if your context is good, you're going to run into problems. It's exactly the same thing in an open note exam. If you studied hard and you know the concepts, but you just forgot, like, is there a negative x on top, or is it a 2x? Or, okay, you can flip through your notes, find it, and then solve the problem. So, well, now those of you who didn't know where I was going with the talk now know where it's going. So someone said that RAG was easy to me one time. They said, yeah, it's easy, man. You put the stuff in the database, pull it out, it's great. It's not, and you have to be careful. And so that's how we get to the fellowship of the RAG, which of course starts with a hole in the ground where you have a documentation system somewhere in your company or in your open source project, and you say, hey, we could take all these documents that we have, we could throw them in a bucket, and that becomes RAG. And then you suddenly find out that it's not quite what you thought. Your walk through the forest all of a sudden gets interrupted by these black riders with creepy fingers that start coming after you. So you start to think, okay, well, who are the people that I need to get this work done? And it starts with a senior engineer, where someone sits around and says, hey, how much of this information can we actually share? How much of this information is accurate? How much of this information is private to our company that shouldn't get out? What are the questions and what are the documents that should be asked about internal things, and what are the things that we should talk about with customers? And then you have your overwhelmed junior developers, which for me kind of feel like hobbits. They're very optimistic, like this is going to be amazing. I have no idea what we're doing, but we'll eventually figure it out. And there was one quote that I love where Bilbo said, I don't know half of you half as well as I should like, and I like less than half of you half as well as you deserve. This is how I feel about all the documentation that I've ever had to deal with. I know there's a lot of good stuff there, and I just don't know what it is. But this is really, it gets into the questions of where are the documents stored? Who are they written for? What audience are they written for? Something that's written for an advanced C++ developer might not be the same thing that you give a frontline support technician. So you have to think about all these things. And then finally, you get a quality engineer. And so I love Samwise for this because he just never quits, Frodo jumps in the water and he's like, I'm coming after you, like we're going to figure this thing out together. And so everyone that's doing quality work, this is extremely challenging because there's so many pieces that can move. You change a prompt, it changes everything. You change the way you store things in a RAG database, it changes everything. You change a model, it changes everything. And now finally, it wouldn't be complete without an AI enthusiast. So we probably all know somebody, or we work with somebody, or we're friends with somebody who just absolutely loves everything. They're reading Hacker News constantly. They're trying to figure out, like, what is the newest, greatest thing, and let's go and try it, and why haven't we implemented it yet? So this is someone that's awesome to have in your corner because they will always keep you excited and hungry to think about the next thing, but you got to keep them in check. So the perfect solution is the enemy of progress. In the end, you're going to be making progress. Things will get better. Then you'll have a setback, and you'll learn something, and you'll make more progress. So now we get to the minds, which oddly enough, when I read the book, it felt like the minds lasted forever. And then I watched the movie, and it was like, was that it? It was like 5 minutes, and they're out of the minds. I was like, what happened here? So you got to start first with a user story. This is the most important part. So that way you understand who you're building something for, what they want, and then once they get it, what are they going to do with it? So for example, like an internal version might be, hey, as a support engineer, I want to search the internal knowledge base about certain hardware configurations or something so I can help customers faster. Okay, well then that tells you like what you need to be doing and how you need to be answering, what documents need to be brought in. External people might say, hey, I'm a sysadmin. I don't want to go read through 15 knowledge base articles to find my answer. I just want to be able to ask it, get the answer, and go, and not have to open a support ticket. Then you've got to get all your stakeholders aligned. You've got to think about who your end users are, and then what information is most useful for the first release. Because the really scary thing you can get into is you could say, well, what if we added a little bit more documentation? Or no, we don't have enough, or let's keep going, and then finally you never release a 1.0. The really big one that really gets overlooked at the bottom is how do we measure our success? Because we all know if you work for a company, it turns into dollars and cents. So you have to really think about if we do this and we do it really well and it's amazing, how do we measure it? How do we know? Do we reduce support burden by X amount? And how do we measure these things? Then you get into like your first stumbles. And then you realize that the documents are very easy for humans to parse, but they're kind of hard for computers to parse. There's a project called Dockling from IBM that's taking off that is really awesome. It can ingest all kinds of different formats and bring them into a standard, like a JSON representation. The awesome thing is that then you have relationships in your documents. For example, if there's like a bulleted list, you can, if you only get half of the bulleted list, you can go to the parent and get the full list, and then go to the parent of that and retrieve the context that was above and below the list. It's pretty handy. You'll need to choose an additional method, your first method for how you want to search your documents, and I have more on that in a second. And then you'll want to score your stuff. So you want to be able to know, is it getting better? Is it worsening? Am I answering the wrong questions with the right answers, the right questions with the wrong answers? And at the end, one thing that's really important is keep your changes small and demo things to your team frequently. That way everyone can benefit from what new is coming from the project. But then you'll get the really excited AI person showing up again, and they'll be like, oh, there's another new Hacker News article. It's like, okay, look, we're going to stay on the path. We're working towards what we're going to do. So I talked about the search strategies. There's lots of different kinds. These are kind of the 4 most common ones that I've seen. The first one is doing a keyword match from a document. So you're trying to match like a keyword or a set of phrases. It's really good if you have really stable like names for your products, or maybe you have something geopolitical and you're trying to get a certain city out or something like that. But you'll miss stuff, like for example, in the US, we might call a truck, and in the UK they call it a lorry. Well, you're going to completely miss it. Or if someone calls their car an SUV and another one calls it something else, you're going to miss those things. And that's where the vector search can help. Because what the vector search is doing is it's trying to find more meaning from the question instead of trying to interpret it literally. And the way that this works, the way the vector search works, is it's just like vector calculus. If you've ever plotted vectors on a Cartesian plane, what you do is you take a model, you take a string of text, put it in the model, and you get a list of vectors. And then you take another string, you put it in the model, and you get a list of vectors. And if those two are perpendicular, then you know, okay, well, these sentences aren't alike at all. But if you get some that are very close, like where the lines, the actual like angle in the middle is very small, then you know that these things are very similar. So for example, how do I wash my car, and I need to clean my van? The keyword search is going to miss both of those. But the semantic search is going to say, hey, wait a minute, these are very similar statements. Then next you've got a graph, which is a relationship. And so that's where you've really got to think about, how am I going to structure everything so that I have relationships between all of my documents? Maybe you would center around everything related to a particular product. Or what I've seen some people do is they say, hey, I have everything related to security, and then that connects to all of my products. So I have a relationship, so someone can ask a security-based question, and then we can go through the relationships to find the right documents. And at the very end, you can combine some of these strategies together. So some people will take the keyword and the vector search together, use the keywords to filter, and then the vector search to narrow down on the exact meaning, or do it the other way. Get the meaning first, and then zero in on the right keywords that come back. And so then the challenge that we run into is these embedding models. If you're doing a vector search, just like an LLM has a context window that's only a certain size, the embedding models are the same way. So if you put in a string that's too long, you'll end up having a big chunk of the string that doesn't get vectors coming back for it. So what you have to do is split and chunk. And these are two separate things. So splitting is when you look at a document and you say, here's chapter 1, here's chapter 2, here's subchapter 2.1, and you split it, and you basically say, okay, I'm going to pull this split out and pull this split out. Chunking is when you go into that subchapter and you say, okay, this is too big to go into the embedding model as one piece, but if I split it into 5 pieces, I can chunk it up and send it through the embedding model and get vectors for each section of text. And so this is where the scoring and judging gets critical, because if you're chunking or splitting in a bad way, you'll find out pretty quickly if you're getting the scores back on these. So if you take bigger chunks, it might not work as well depending on your document. Smaller chunks might make more sense. So then you'll have the AI excited person come back and say, just put the PDFs in the bucket. We're going to make a RAG database. And you say, okay, look, we have a plan. And then some documents just won't bend to your will, no matter what you want them to do. Does anybody remember what the scary creature was? Balrog. Yeah, there you go. So yeah, you'll run into these documents that are just, you look at them and you're like, oh my gosh, there's charts everywhere. And then how many of us have ever jumped into a PDF and said, oh, this looks great, I'll be able to parse this, no problem. And then you realize it's scanned pages of text, like it's not actually digital text, like it's a PNG stuck in a PDF. Oh, it's bad. So in some of these situations, you just say, look, you're not going to parse it. You shall not parse this document. Those are great documents to set aside and ask for help. And so the two biggest things is keep the end in sight. So if you get to a set of documents that are really stuck and someone says, we need to be able to answer questions about these, you can go back to them and say, well, if you want me to answer questions about these, we got to find somebody to improve them. Somebody's got to do the OCR work. Somebody's got to go and reorganize these or break these up into pieces or update them or something like that. And on the right side, the number one thing is garbage in, garbage out. It's the same with any other thing. If you put in low quality documents that are written for the wrong audience or they're inaccurate, well, guess what? All that information is going to get sent to the wrong audience and it's going to be inaccurate. Let's see. And so then you'll end up with some failure scenarios from time to time. So the first one on the top left is where you get an incorrect response, where you search for something in the RAG database and it's just the wrong answer. Maybe it matched on accident or something like that. It'll usually confuse the LLM and you'll get into a strange situation. This is one where you have to go and debug when you use the embedding model to create the vectors for the vector search. Maybe your parameters were wrong. Maybe you're searching with an embedding model that's different from the one that you actually encoded the vectors with. And at the bottom left, the correct and incomplete. So I have this thing where I love to talk about it at work called the beef Wellington problem. How many people have seen like Hell's Kitchen where Gordon Ramsay's screaming at people? No one can make a beef Wellington right. It seems very complicated. But there's a long list of steps to make it. And so if a user says, I got to make a beef Wellington, help me out, and we give them steps 4 through 8, and there's 20 steps, is that helpful? Well, it's correct, but it's not complete. And so that's one of those things where you can actually expand that context with projects like Dockling. And the LLM hallucination I'll get into in just a second in some more detail, but that's where the LLM gets stuck in a situation where it can't make a statistical probability analysis about what's been asked, and then it just kind of goes crazy and starts just spitting out things that don't make any sense at all. And then finally at the end, like there's correct and irrelevant things. So if a user says, hey, how do I reset my password? And you give them instructions on how to create a very secure password, like letters and symbols and things like that, it's helpful, but it doesn't answer their question. So it's kind of part of what they need, but it's not the right thing. So getting into hallucinations, LLMs will hallucinate when they kind of get on the edge of their knowledge abilities. So if you pick up an LLM that's been heavily trained on calculus and nuclear physics and lots of scientific topics, and you try to talk to it about Shakespeare, it might do some weird stuff, and you're not really sure what it's going to do. So it's something you have to be careful about when you put it in front of customers. So if your RAG results are, if they're accurate and complete, but yet the LLM does not know enough about what you're answering. So let's say you get in that situation and you start supplying Shakespeare as context, the LLM will still have trouble dealing with that, even though you provided like perfect context for it to use. It just doesn't have knowledge in that area. So in this case, you might have to switch to another LLM. And when you're looking at LLMs, it's the size of the models that really matter. So the larger LLMs, like the ones you find like Claude or Gemini or OpenAI, these are massive. They are trained on an unbelievable amount of material. And so with these, your RAG quality and RAG completeness is not really as important because they've been trained on so much already. And some of the larger models that you can run locally, like even Llama 4, Scout, and Maverick, they've been trained on so much. And then the GPT OSS 120 billion parameter model came out recently. They've been trained on a huge amount of material. But if you do move to a smaller model, your RAG quality will have to be much higher. So if you get down to something like an 8 to a 24 billion parameter model, you'll have to do a lot more work with RAG. All right. And so finally, we'll get into the road goes ever on. So this is what happens when you finally get to the point where things are starting to work. So you need to find a way to develop a pipeline, because as soon as you have something that works, everyone's going to come out of the woodwork and they're going to say, hey, can I get my stuff in there? Can I get my stuff in there? And what is the scariest part if people start adding stuff is that the quality goes down of the responses. And then everyone looks at you and says, well, who broke it? Okay, well, you have to have the answer to that. So the number one thing you do is find a way to identify those knowledge gaps. Like find the questions that your users or your customers are asking where the results are not very good or the scores are not very good. And then add or update existing documents. And then you bring them in and then you judge them. So you try to figure out like, hey, after we add this document, do our searches get better? Do they get worse? And if they need to be refined, then you refine them and try again, judge them again. And just as I said before, like the 15,000 page PDF, with the Balrog and everything, sometimes you just have to say, look, this document's not going in. And it's not going in for these reasons, and if someone has cycles to go and fix it, let's fix it. And at the end, you finally can add it to your production RAG, and it improves, and you're confident that you haven't made anything worse and that you've actually improved something. And then you'll arrive at the done enough. So this is kind of that 1.0 moment. And this is different for everybody that's working on one of these projects. But you'll get to the point where you're ready to launch. Your accuracy is always going to fluctuate over time. Maybe it'll go down, maybe it'll go up. How many people have sat down and used, the GPT-5 that just came out? It's weird, isn't it? The experience is different. Sometimes it goes up, sometimes it goes down, sometimes the way you have to prompt is different. But in the end, you'll finally go to a point where you say, hey, this is good enough. Like, let's give this a try, and then we will iterate and keep going forward from there. And this is always a great point to just keep identifying those troublesome areas where like, you've got knowledge missing or there's certain types of documents that are really difficult to deal with. And then, of course, you get to the first production deployment, which always makes me sweat. And there's a great quote from the Two Towers. It says, "But late in the night the watchmen cried out and all awoke. The moon was gone, stars were shining above, but over the ground there crept a darkness blacker than the night. On both sides of the river it filled towards them, going northward." How many people think this feels like when you deploy to production that first time and you open it up to customers? This is kind of like what I have going on in my mind. It's like, okay, it's on now. And so this is where you start thinking about things where when there's a high volume of queries coming in, regardless of the quality of the responses, can I handle the amount of responses that are coming? And how am I going to deal with that if I can't? You'll want to make sure you have logging of queries, provided that your company's compliance programs and various like legal requirements are there. If you're able to get a log of what was asked and the response and the RAG results that came back, it'll allow you to play that back later and say, okay, what exactly went wrong? Did we have a bad RAG search? Did the LLM kind of do something strange? You can kind of work through that. Finding internal testers is really good, and make sure that you have a method for them to give you the feedback in a constructive way. Because you will have a lot of people. We know, like just like Gollum and the AI excited people, how many of us know people that just absolutely hate AI and won't touch it and they think it's the worst thing ever? Yeah, we all know people. Those are the people where you want to focus their efforts in a good direction. And you want to say, hey, look, I know you didn't like that response. How would it have been better? Like, where's the correct response? Show me the piece of documentation or where this is where it's correct, and try to find a way to bring it in. So over the last year or more, we built a product at Red Hat called RHEL Lightspeed, and the goal is to make it easier for people who are administering RHEL and other Red Hat systems to be able to ask questions and get help. And so free up time for those kind of the senior sysadmins, and then also help junior sysadmins be able to operate a little bit more like senior sysadmins. And so there's some lessons I've learned along the way. And hopefully you picked this up, is that RAG's not a destination, it's an ongoing quest. Your documentation is going to change. What people are asking of you is going to change. Your products are going to change. The places you operate are going to change. The complexity of your products are going to change. And so all this whole time, you've got to think about this is going to be an ongoing quest, no matter what. If you ask anybody that works on documentation on any project, it is always an ongoing quest. You're never done. And your fellowship matters a lot more than your technology stack. So when I said in the beginning, when you get people together and you agree on the user stories, you agree where you want to be, you agree on where the customers are that you want to serve and how you measure your success, it is really important because these things get really hard. Start small, fail fast, and learn constantly. So this is always find a way to make it very easy to contribute material to a RAG database, make it really easy to score it, make it dead simple for people to know that the document that they brought is in bad shape. So get it to a point to where they can make a pull request in a repo and get a grade. And then they say, wow, I brought in this document and got my grade's a 30. That's terrible. And then give them the tools they need to go figure it out and say, hey, your document's too long or your document doesn't have the right keywords. There's all kinds of things you can do there. And that goes with just measuring everything and optimize what matters. So I've seen people go and they optimize on the database to make it as high performance as possible, and then the amount of queries they're getting is actually very small, and they're all served in a certain amount of time. So just focus on what really matters. And the last two things, your documentation quality matters so much more than your RAG strategy. It is extremely important. So it's a garbage in, garbage out type of situation. So if your documentation is not in the state that it needs to be, it doesn't cover the content that it needs to cover, doesn't have the right keywords, work on that first. This is the number one problem that I see when I talk to people, or like, how many people have gone, there's a RAG subreddit, and it is amazing how people are like, oh yeah, I just split and chunked 55,000 documents and it's amazing. And then they're like, but I can't get any good data out of it. And the first question people are like, well, did you look at the data before you put it in? And they're like, well, does that matter? I'm like, yeah, no, it matters. It's required. So that's one of these things where, at least within our team, we've been able to go back to other people and say, we would love to include these documents, but here's what needs to happen first. Like, this is really good knowledge in here. Unfortunately, it's buried in, some documents that need to be updated, or they're written for the wrong audience. So let's try and figure out how to do that. Oddly enough, you can use LLMs to extract some of this stuff and improve some of these documents. So if you have a very lengthy document where there's only a little bit of information in there that you really need, have the LLM extract it for you. Say, hey, here are the 5 guidelines that are really important to me for a document going into RAG. And you'd be amazed what LLMs will do if you keep them on a very short leash. All right, so that's my talk for today. And if you want a copy of the slides, the QR code will hopefully take you to Google Drive. If it doesn't, let me know, and I will quickly go and fix it. And yeah, what questions do you have? I think we got a handheld mic. Oh, thank you.
Hi, Major. Thank you for your talk.
You're welcome.
That was incredibly interesting as someone who's interested but not knowledgeable. I appreciate your presentation style. The question that I have here is that you point out that there are several stages here that we need to take care of, right? We need good stuff going into a system. We need a system that's going to be resilient enough for the usage. And we need a feedback pipeline for people to be able to put stuff into the system or modify and make it better. My question to you, though, is as an enthusiast or as someone who wants to prototype and play with this kind of stuff, maybe locally or looking into how to do this in security and privacy-centric places, like let's say you work for a company that's dealing with trade secrets, but you want to be able to have some internal knowledge base that is accessible and indexable through some interface, and then you have RAG on top of it. I have 2 questions. One is, what breadth would you say is a min-max? How much and how little data make a particular instance of this useful? And and so what I mean by that is just like how much data in the RAG portion. And then the second question is, how much of this data needs to be in the LLM rather than from RAG?
Okay, so let me see. I'll answer the first one first on the breadth question. So I think one of the best ways to get started is get an LLM running locally, which we can go into that too, and ask it a question with no RAG, and just see what you get. And sometimes you'll be surprised. It's pretty good. Now, if it's specific or you've got proprietary software or it's an internal company thing, now of course it's probably not going to be that great. So at that point, it kind of goes back to the beginning where you write that user story. So like, for example, as a support engineer, I want to be able to answer questions about this part of our product, or maybe just this one product. And then you tackle that problem. And so then you say, okay, well, what documentation do I have that goes with this product? What quality state is it in? How keyword dense is it? Or is it broken into sections, or whatever, that kind of thing. And then you start small and bring in pieces of it, ask your question again, and say, oh, wow, that did get better. It is pulling the right stuff out. Or, oh, no, it didn't, and let me go try and find out why. But I think you have to think about that first release and getting to that point, that first release where you can turn it over and hand it to somebody and let them play with it. So I would say start with a really small breadth, because it's much easier to change gears and change a lot of settings when your data set is small than when it gets really big. So I would say start small. One easy way to do that is with Ramalama. So there was a really good talk at DevConf in Boston a couple weeks ago, and it's recorded if you go on YouTube. And it was by Dan Walsh, and there's another gentleman at Red Hat, and his name is escaping me right now. And they did a demo of Ramalama with rags. They took a PDF and jammed it in there, and were able to ask questions about it, and it was pretty cool. And then what was the second part? I got excited about your first one, and I forgot about the second one.
No, the two parts were how much data goes in RAG versus how much data should be in the LLM.
Right. So how much data in the LLM was the second half? It really depends. So when you look at what's available right now, like what most people call like the frontier models, so Claude and GPT-4 and stuff like that, they've been trained on so much material, now not your proprietary material potentially, that you should be able to answer almost any question that's like on the edge of its knowledge and provide that context pretty well. Now, if you go and grab like an 8 billion parameter model or something you could run on your laptop, most times you're probably going to be okay if you get like a broadly trained model, like if you're doing something from Llama or like IBM Granite or I'm trying to think of some other, Mistral's got some small ones as well. You're probably going to be good and the subject material will be close enough. But yeah, it won't be the same experience that you get from the big models. But you also have the opportunity to fine tune the model. So you can bring down a model like an IBM Granite model and then you can train it. The only thing I would advise you on that part is that RAG data quality has to be really good. When you fine tune a model, it's got to be really good. Like, I mean, serious. So the example I like to give is that LLMs are completely based on statistical probabilities. So it would be like me going and walking into the nearest 7th grade classroom and being like, hey guys, right angles are actually 95 degrees. Your teachers have been lying to you the whole time. Well, it's going to ruin their education for the rest of their life. It's the same thing with an LLM. If you go in there and give it one bad piece of fundamental knowledge, the whole thing is toast. It's rough. Hopefully that answered it.
Thank you. This was really good.
You're welcome.
I was curious about the ingestion into the reg pipeline. One part of that process was scoring it to understand how good that is. Can you talk more about how you're scoring it? Is that an automated process? How are you judging that? Yeah.
So there's a ton of projects out there that do this. I think IBM's got one called Judge It, like Judge-IT. There's one called Ragas, R-A-G-A-S. I've seen a whole bunch of other ones come out. But honestly, you don't have to do anything terribly fancy. It's kind of like you just want to get some kind of grade that is close to deterministic. So for example, what some people will do is like, let's say they're doing all their questions against OpenAI, and they want to be able to grade the responses depending on how they change the RAG. Then what they might do is grab another model. Like maybe they get a subscription to Claude, or maybe they download Mistral or Llama locally, and they set what the grading is for the response. So for example, 50% of the grade is if it's correct. Obviously, that's pretty important. But complete, okay, well maybe that's 25% of the grade. And then you have to give the LLM a way to actually judge it and say, here's what I mean by complete. It contains all the steps needed to solve that particular problem. And then try to keep that prompt, whatever you use for the grading, try to keep it as stable as possible, because the moment you change it, of course, it changes the grades for everybody. But that's one simple way to get started. But yeah, there's a lot of projects out there that are doing that now that you might be able to stand on the shoulders of other people doing it. Hopefully that helps. What other questions?
Yeah, hi. So my question is like we have the MCP tool calling where the LLM dynamically searches for the context itself using the tool and dynamically fetches the context and then it tries to respond. So here RAG is somewhat like statically configured. So how we go about that?
Yeah, so a quick refresher on MCP. The idea behind MCP is to be able to hand an LLM a set of tools, and you tell the LLM, okay, this tool does these things. Like maybe this tool does a lookup in my customer database of a customer. And to do that, you need to have a customer ID or a customer name, let's say, or something like that. And then what the LLM will do is it'll get a question and it'll say, to be able to answer this, I've got to go use this tool that someone told me about, and it will make an API call into the tool, get the response back, and use it as context. So it's a very high-level explanation of MCP. So you can do RAG through MCP. And in fact, that's probably the most modern way to do it. I've seen some people that it will even go so far as to have like, I'm trying to remember, it's like a BERT model, a BERT model that will understand the intent of the user's question, and then help you break that down into like, which RAG database should I look into? So you're not searching everything all at once in your RAG database, you're laser pointing down into like whatever data that the customer is looking for. So there's that option as well, but you could certainly do RAG this way. And some people will do it with an API request against another system and get data back and then use that as part of the RAG. For example, like if you go to ChatGPT and ask about your local weather, it's going to use a tool to call out to a weather service to get the latest thing, use that context to then reply to you. Did that answer your question?
So my question is on the observability and cost. So let's say you've done your testing, you think this is good. Now you kind of want to monitor how well it's performing in the wild and the cost. Which tools or strategies have you seen best for that?
So I would say the costs here, like the biggest cost you're going to deal with is if you're running the LLMs yourself, it's going to be the GPU expense of actually having the GPUs. And then if you're consuming an API like something from Claude or OpenAI or Google, then it's going to be your input tokens, your output tokens, your reasoning expense, and all that kind of thing. So that's where things can get a bit tricky because you're not entirely sure how big the questions are that you're going to be asked, and you're not entirely sure how big the responses are going to be either. So I haven't seen too many tools out there available for estimating that.
I've seen some.
Oh, okay.
Yeah, there's a lot of observability tools out there, and I'm just curious if you had experience with any of them and which one you.
Yeah, so I guess the question is around the observability tools for cost and things like that. I have not messed with those too much. But yeah, no, I think that would be just trying to find a way to keep your LLM costs under control and keep them optimized.
It'll show you like what the questions are and kind of how many tokens were used.
Oh, yeah.
Yeah, it gives you all that information, but there's just a lot out there, so it's hard to decide which one's best.
Yeah, there's a lot of information out there. And yeah, that's one tricky thing as well, is that if you're deploying this all yourself on your own GPUs, or you're going into AWS or something like that, look at how much these instances cost. They're not available in the spot market very often either. And then if you're consuming it from a vendor, look very, very closely at their input token and output token cost. Very closely. Because sometimes there'll be little gotchas and little asterisks in there hiding out and things, and you'll look at it and you say, 1 million tokens? Oh, I won't use 1 million tokens. And then 80 billion tokens later, you're like, what exactly happened? Oh, one in the back. Or,
My question is, you mentioned what you guys had done successfully with this. You mentioned what you had done successfully, the project that you had delivered. Were there some use cases that you identified where we're going to stick with traditional indexing and search for cost reasons or other stuff? What were things that you looked at and you said, oh, we learned this isn't a good candidate for LLM, or we're going to keep this the way it was, or those types of things?
That's a good question. So I think in the beginning, we really wanted to have it be a chatbot, because that was our initial goal, to be able to answer those questions for users. And then some things came up around like, well, what if we execute commands? Like, what if we actually like offer to execute the commands? And then we started thinking about the auditing pieces of that. And so it kind of got into, when I say find out what your good enough is. And so that's where we said, okay, wait a minute. Because it gets in a situation where if you tell me, hey, I need you to go fix the thing, and I go to the AI and I say, hey, help me fix the thing, and the AI says, man, if I just chown the whole file system from / for your user, we'll fix it. And I'm like, cool, let's go. And I hit the button. Is it my fault, or is it your fault, or is it the AI's fault? Like, we'll have to sit around and think about that. So that was something we avoided doing. I will say, though, that one of the things we found was when we built the vector database, we would just rebuild the vectors every time because we weren't quite sure if something had changed along the way or configuration. And then after a while, we would pre-build them. And so that way we're not, rebuilding all these things. Because when you embed the vectors for a vector store database, you'll need a GPU. You could do it with CPU up to a point, and then you'll be waiting a very, very long time. Trying to think of what else. No, not too much. I think really the biggest thing is just trying to keep things in scope, because this world is moving so quickly, and if you try to keep up with it, it's tough. You just got to set like, okay, here's our point, where the capabilities are that we want to have, and let's go.
Hi, so I was wondering about the embeddings in the vector database. Typically, when you do something like that, you have to use the same embedding or the same embedding LLM to be able to consistently get the same data out.
Right.
Is there kind of universal one, or has that improved at all? Or are you still married to the one you pick when you first do the embedding, unless you want to re-embed everything?
Oh yeah, there's tons. And depending on the language that you're embedding, so like whether it's Chinese or English or Spanish or Portuguese or whatever, there's some that are geared for certain material. There's some that are geared for very scientific material. But yes, when you embed all of those things into vectors and put them in your database, you're going to need to have that same embedding model available to you when the search comes in. So when the user says, hey, look, like what is the, how do I write a find command that changes the permissions of files in this directory, you're going to need to do a lookup and then use that embedding model for that. But what I recommend people do is on Hugging Face, there's the MTEB, the model something. It's like the leadership board of the embedding models. So it'll tell you, and you'll be able to say, hey, I'm very interested in retrieval. Like I'm very interested in RAG, and it will resort the list as the ones that are scoring the best. Or you can say, I'm very hardware constrained, like I don't have great hardware to use, and it'll show you the ones that are the most efficient. And so then you can kind of pick out what you want. And some people actually do a matrix of multiple. So they'll have 2 or 3 different embedding models they store in their database, which then gives them flexibility later to say, okay, in this situation, when we go on premises and it's on a little Raspberry Pi or something, I'm going to go with the most efficient model because it's already in my database. But then when I'm in AWS, maybe I'm going to use the biggest, best one that I've got. So you have those options.
I wanted to ask a little bit about the RAG pipeline when you did Lightspeed, and how on the people side, when you rejected the document and how good it was, less garbage in, how did you ask the people? Like, how did you say, hey, this is how we need to improve it? Or, how did you get that data and be able to say that those were the bad documents and, metrics and all on that?
Yeah, so for those, like we had a lot of really good material, but it wasn't good for going directly into RAG. So it was one of those things where you look at the document, you're like, wow, this is really useful. And then you're like, I would hate to put this in a RAG database. It needs to be in a different format, or it's got, like for example, we have some amazing articles that are written by support engineers where they've got kernel dumps and all this stuff in there. Well, I can't take the kernel dump and put it into RAG. So you have to go through there and kind of, Dockling helps out with that a lot. So a lot of it is going back to teams and just saying, hey, you've got great stuff, and I want your knowledge in this database, and I want to be able to answer those questions. But here's what I need from you. Like I need it to not have this stuff in it, or I need it to be written for this type of audience. So I think that it's one of those situations where you don't want to make it sound like that their data is not good. It's just, it's not good for this particular purpose. It's good to put in front of customers. It's good to share with consultants. All that is great. But in this one particular instance, it needs some things done to it. Any more?
When I ask AI Lightspeed a question, where does my question go?
So it depends. So are you talking about rel Lightspeed?
Yeah.
So the question was where does your query go? So at the moment, your query goes into our backend API, which is the same. If you run any of the Red Hat Insights products, it's going to the same place. And then we do all the processing and find the correct RAG data there. And then we do our inference at watsonx, so at IBM. So we do the inference with a Granite model that's hosted there. All right, anything else? All right, well, thank y'all so much for coming.